one of the things one can do if one images the wrist, it allows one to image the amount of radioactive material inside the radial artery. Now, this is a little complicated, but if you have that information while you're doing what they call a dynamic PET scan, while you're making a PET scan movie, it allows you to do something called parametric imaging. It allows you to work out exactly, for example, how much glucose the tissue is using, or exactly what the rate of binding is of a particular agent to a particular organ. And if we don't have an ability to measure what's in the blood, we would then actually have to take what they call arterial blood samples. You actually have to draw out rapid blood samples from an artery and measure the blood samples in a well counter. Now that is not simple, it's not funny, and it hurts. So you can get research subjects who'll do it, but they're all very brave. It's much harder, very, very tricky to do. So much easier if you can measure that with a little scanner. So we could use a wrist scanner for that. And then that has applications in neuroscience and all sorts of things.
Great. Are there many people working on this project right now? How many researchers are working on this project right now?
So here at UC Davis, we've got, they're not working full-time on it. So we've got maybe Abdullah working full-time on it, and then I've got like 1, 2, 3 other people who are working part-time on it.
Okay. And do we know anything about the official launch date of the project? The technology?
So what do you mean? When we think it'll be ready?
Yes.
I want to say about a year and a half from now.
So it's an ongoing project. So there are many final touches to be put on.
Absolutely. There are lots of things that we still have to do here.
There are lots. So it's a very ambitious project, if I'm not mistaken.
Well, so I think I'm pretty confident about the hardware. One of the areas that's going to be a little bit more tricky is the software, because we have some prototype software that you can tell it roughly where the detectors are, and it'll work out how to make the images. But there's a limit to the number of configurations of detectors that it will support, and we need to make that software more general purpose than that. And that's going to take some effort to do that. I don't think it's not scientifically impossible. It's just a lot of manpower. It's going to take hours to do it.
Dr. Cherry also told me that there are right now 3 PET projects at UC Davis. 3, at least 3.
Yeah. Oh, there are many. Yeah, we have a big group here. So Dr. Cherry and I are working on this giant PET scanner. This is the Explorer project.
Yes, he told me about
so we're co-leads on that. Then Dr. Martin Judenhofer, who also works on the Toolkit project, he's building a combined PET MRI scanner, a PET scanner that will actually fit inside an MRI scanner. So those are the main PET instrumentation going right now.
So my last question for you is this: do you think that are there any potential setbacks and limitations in this study, or better, in the wider PET research? Is there something that needs to be further examined, or, as I said, are there any potential setbacks that you're still, around which you're still working? Do you find limitations, serious problems? Because, we don't want to paint everything through rose-tinted glasses. We need to be a bit, subjective. This is science objective. This is science after all. What's your opinion?
I think that I'll give you 2 answers. One is the general PET situation, and the other is specific to Toolkit.
Okay.
With the Toolkit, I do not think this will be successful unless we get a commercial partner.
Okay.
Because I think that it's not reasonable to expect a science lab to be able to support at a distance all the hardware and all the software for another lab. That just doesn't make sense, because the science lab has to write papers, otherwise it dies.
Yeah.
And you don't get papers from just fixing bugs from, basically just maintaining another person's scanner. So really, what you need a commercial model to make that work. So what I am hoping is that we will demonstrate the feasibility of the toolkit, and then we really need to persuade a company to take it and run with it. And if we can do that, I think there's a future for it. And if we can't, then I don't think there's a future for it. So that the toolkit, that's the bit that I think is the biggest hold up there. That will make the difference between final success and failure.
I see.
Now, in the broader scope of things, there are a bunch of problems that are seriously unsolved in PET. I mean, there is a lot of problems with subject motion, for example, that are not well solved right now. A lot of people working on that area. One of the real issues also, I've talked to you a little bit about measuring the amount of radiation in the blood with a scanner. That works for some kinds of radio tracers, but it doesn't work for all of them. There are some radio tracers that get broken down into different chemicals in the body. Now, those ones, you still need to pull arterial blood samples to measure the metabolites in the blood. And that is a big problem, because that makes it very difficult for a non-specialist site. There's very few sites in the world that can really do that well. That fits PET applicability, because it means that we can only really easily use tracers that don't break down in the blood. And there are lots of really interesting ones that do. So solving the metabolites problem, that's an ongoing one, and that's something that you could talk to Rich Carson at Yale, and he would spend a long time explaining why that's really difficult. But that's one of the ongoing limitations in PET.
Okay, great. I am covered. Thank you very much for your time. It's been great speaking to you, and thank you for sharing your insights with us.
So if there's one thing I may say, and you can tell me if I'm being inappropriate here. So typically we give interviews and we don't get sight of a copy because that's the way it works. But I know that this is going to Proto Magazine, which is at Mass General.
Yes.
So it's extremely important to me, reputation-wise, to make sure that we've got all the facts correct in this article, because it's going to one of our peer medical schools. So how do you feel about allowing me to look at the copy before we go to final print?
Well, okay, yes, this is a bit of a touchy, thing for journalists.
I understand.
Usually, yes, I'm not very sympathetic to the idea, but in this specific case, because I don't only write articles about science, I do investigative journalism, I do human stories, and when, people make this question, it kind of rubs me the wrong way, because then it's not journalism, it devolves into PR. But in this specific case, we are talking about something highly technical.
Yeah.
So it makes sense, it's kind of convenient for me also, because I don't want to write something that is mistaken. I don't have, some major disagreement in this specific case, because the article is highly technical, highly technological, highly scientific, and it would only be good for the quality of the final result to have a pair of expert eyes, on it. So
how about I agree to limit any corrections I make to simple statements of fact?
No. If you think that something is wrong and is not true or is not scientifically correct, because the target reader of Proto Magazine is the physician.
Yeah.
It's basically, so you can interfere. There's no problem with that. Because, I'm making an exception because this is a really difficult article. And I've written for Discover, I write for Science, I do a lot of science journalism, but this is my first for Proto Magazine. And I would also not like to jeopardize, my future chances with them. So I don't have any problems in this specific case. So I'll send it to you. Do you want me to send it to you or to Abdullah? To you.
Send it to me.
Okay.
To me, and I will as I say, I will just give you my opinions on the correctness of the statements made.
Okay.
So if you have any editorial or views in there, I won't make comments on that. I'm just going to make comments on the actual scientific facts.
Feel free to correct everything that is not factually correct anyway. It's just that I have to file by March 7 at the latest.
Okay, I got it. I understand.
I have to write at least 5 articles more before that. So
yeah.
I'll send it to you if it's okay, at the beginning of next week. So if you're available, just, have a quick look at it. It's just